Hey, my name is Jesus Castelló for rubyguides.com, and in this video you're going to learn about the stack data structure in Ruby. What is a stack? A stack is an amazing data structure with only 3 operations. These operations are push, pop, and pick. Push, pop, and pick. In Ruby, we don't have a stack class, but we can use an array as a stack and only use these 3 operations. So let's see an example. In here, we are pushing 3 values. Pushing is just adding values on the top of the stack, adding 1, 2, and 3. And the way a stack works is we are always adding new values on top of the old values. So it's like a physical stack of cards or something else. A stack of plates. You put a plate on top of the other plate, right? And when we pick the last element, like this, we're going to see what's on the top of the stack. We call this the top of the stack. And we don't remove the element, we just take a pick and see what the last element, the most recent element is. And this most recent is the main use for the stack. When you want to know what the most recent operation, the most recent value is, then you use a stack. This can be used, for example, if you are implementing an undo feature. For example, in my editor, when I delete something or I make some change, like I delete this, then this change goes into a stack, into an undo stack. When I tell my editor to undo that, it will pop the stack. It will remove the last element from the stack and then undo the operation. So to remove an element from the stack, we pop it. We do it like this, stack.pop. And this does 2 things. One, it removes the element, the last element from the stack, and it gives you that element. So if we print this, we can see that we get still 3, but if I pop again, stack pop, there we go. Now I get 2. If I pop again, I get 1. If I pop again, we get 0 because we are done. So notice another characteristics of stacks. I added the elements, the numbers, into the stack in sorted order, in ascending order. So 1, 2, 3. But when I pop the elements, I get them in reverse order. So that's another use of stacks. If you wanted to reverse something, yes, there is the reverse method in Ruby, but it's another way to do it. You could use a stack, just put everything in the stack, and then pop everything from the stack, and you get the things in reverse order. So that's another characteristic to keep in mind. So let me show you another example of how to use stacks. Let's say that we have this multi-dimensional array, and it has arrays inside arrays. And we want to print all of the numbers. One thing we can do is to use a stack. We treat this as a stack, and then we do a loop until the stack is empty. We pop one of the elements, and if the elements is an array, then we put all of the sub-elements, all of the items of this array, back into the stack. So we push them back into the stack. Else, if it's already a value, it's a number, then we just print it. As you can see, we get all the numbers in reverse order, because remember that's one of the characteristics of a stack. We get the reverse order. That's one way to use a stack. You can check if it's empty until it's empty, and then pop the items and push back the items that still need some work to be done. It's a substitute for recursion. Recursion is a method that calls itself, and that's one way to do this, because this could be infinite levels of arrays inside arrays inside arrays. You can know how many arrays are, how many times you have to loop, right? Because it can be infinite arrays inside arrays. There is no limit. So since you don't know how many times you have to loop, what you do is use the stack, and then you loop until the stack is empty, meaning that you already process all of the elements. And this can be used for other things like solving the balance parentheses problem. So you have something like this. The balance parenthesis means that there is an opening parenthesis, and this opening parenthesis has a corresponding closing parenthesis. Since there can be an unlimited amount of parentheses like this, then one way to solve this is to also use a stack. And the process is very similar to this. This is the stack data structure, super useful when you have recursive-like structures, when you want to keep track of the last element, the last operation, and you want to have like this kind of undo stack, undo feature. It can also be used for backtracking, like you're exploring all of these paths, and as you're going through these paths, you are finding other paths, but you don't want to go through these paths yet. You want to write down that you found these paths and explore them later. So you keep looking for the current path, and when you find the end of that path, you go back to the stack of found paths and pop one of these and then continue. And that's how you can navigate a graph data structure or a tree-like data structure using this logic. This is called the depth first search, because you go all the way to the end, and if you're going through the steps, you are going to finding other possibilities. You have these possibilities, this work to be done, these ways to explore into the stack, and the stack allows you to keep track of these pending operations. So that's yet another possibility for using stacks. Just one more thing, notice that in a stack, unlike an array, you don't access elements by index. So this, if I do this would be an invalid stack operation, because in a stack, the only thing you can access is the last item. The last item using the either last to just see it and not remove it, or pop to remove it and get it. So this is not valid in a stack, only these three operations. So remember that only pop, push, which is this, and pick or last. If you remember that, then you will be using stack correctly. Only work with the most recent item. That's the stack data structure. I hope you found this useful and interesting. If you did, please give me a like, so I know that you like this video. And if you haven't subscribed to the channel yet, do it now, because that will help you keep improving your Ruby skills. Thanks a lot for watching. See you in the next video.